Have you ever tried going to sleep but couldn't because you knew that you don't know how a gearbox or a transmission worked and that made you feel like really sad? Quick disclaimer, I'm just a guy that really likes to nerd out about anything car related and one that wants to learn how any of these things work. And apparently there's a learning method when you explain a topic to someone and you just automatically learn it yourself. So that's what I'm gonna do. So by far I'm not a mechanic nor any type of engineer, so some info of this could be wrong, but I'm gonna try my best to get all of this right. Okay, here we go. A gearbox, Latifi's biggest enemy, is a fancy mechanism made of many gears that's primary focus is to adjust the speed and torque which are produced by the engine, whilst trying to keep the car moving at an efficient speed by changing the rate at which the engine's crankshaft is spinning. Okay, that's a lot of words to take in. In simple words, it tries to determine the most efficient speed at which the car's wheels should spin based on how fast the engine is spinning. This also includes the gearbox adjusting the torque of the car, which essentially means how much force the engine applies to spin the wheel. And obviously more force means more rotation for the car's wheels and less means less, you know. Now, why the hell do you even need a gearbox if I can just, I don't know, strap on a thruster old Gmod cell and call it a day? Well, firstly, I hate you, and secondly, there's several reasons not to do that. Firstly, you could do that, but that's stupid because you would need two thrusters to be able to go forward and reverse. And you would burn so much fuel in the process with a precision for gradual acceleration that's comparable with Paris' entire 2024 season performance. Secondly, a gearbox helps you drive comfortably by adjusting a proper amount of torque to the wheels when starting to move from an initial rest position, because it's way harder to move from rest than it is to move to an already moving object. Why? Because of the beautiful thing that is inertia, which is defined by Wikipedia as the natural tendency for an object to stay in motion when that object is moving unless any external force interferes. Or in a way which I like to call it, if you're rolling, but if you hit the gravel, you're flying straight into a goddamn wall. That's why the car has higher RPMs when moving at faster speeds and lower RPMs when the car is just trying to move. At rest, it focuses more on applying higher torque to get the car rolling into some sort of inertia, whilst when trying to get the car to go as fast as possible, the RPMs of the car's engine increase because inertia already helps the car stay in motion. And that means that there's way less torque required to make the car go faster, and so the car's RPMs increase because there's lower torque applying to the wheels that helps get the car to even faster speeds. Sweet. However, how does the actual whole mechanism work? Firstly, it depends on the amount of gears that a gearbox has. Your crappy ass Corolla most likely has 5, your granddad's beaten up Audi 3 probably has 6, and most race cars have even 8. All of these gears differ in size because the bigger the gear's length, the more torque it can produce, which can be explained by its torque formula. And as stated before, more torque is needed in moving from rest, so that means that lower gears use bigger gears to function. The main way this whole complex mechanism works is actually fairly simple. That's if you explain it, in a simple way. There are two shafts that a gearbox uses, and that is the main shaft, and that is where the gearbox receives power from the engine, and the counter shaft, whose purpose is to regulate that power incoming from the engine to the main shaft by meshing with the according gears. Now, the amount of gear teeth that each gear does differs, but that's once again due to torque. When more torque is needed, more teeth are needed to get a bigger force to move the engine's crankshaft. Once again, bigger gear teeth ratio are for lower gears, whilst for higher gears is the opposite. When you shift into a different gear, you use the clutch to disconnect the gearbox from receiving engine power, which is incredibly important. You know this, but why? Because in order to select which gear you want to be in, you have to use these little hubs and rings that will mesh with the desired gear. Okay, how does it do that? All of these gears are running on these hubs, which allows the gears to spin independently of the main shaft. This is very important. This allows us the ability to use these connectors, forks, to connect the desired gears to the actual main shaft so that it spins based on the power that is received. And the reason why it's important to disconnect the clutch is because the clutch stops power transmission to the gearbox, which makes it actually possible to synchronize the gears with the connectors. Otherwise, you're going to grind the living hell out of the gear teeth, eventually leaving your gears looking like used Pirelli tire. Unless you drive a Golf, then you can do whatever you want. These things are low-key unkillable. A differential is a mechanical car device that manages the difference in the speed of wheel sides whenever a vehicle performs a turn. Keyword: Difference. Here's a very simple example. When you're trying to turn into a specific turn, let's say it's the first turn of the Australian circuit, you're most likely gonna miss it, but it's not whatever. When you're turning into that turn, the left side, when you're turning into that turn, the left side, the side outside the turn's entry, is going to travel a much longer distance than the right side, which is the turn's entry side. That is because the radius of the turn is much smaller on the entry than it is on the outside. And in order to get the car into the turn smoothly, the left side of the wheels would have to travel at a faster speed than the right side. Otherwise, if both of the wheels were welded together to like a single strip of metal, you would not only slide into that turn and have a lot of understeer, but would also very quickly get your tires used up from the friction they would have to stomach that slide. Now, how does the differential mechanism work? The differential, which is at the very back of a car, is connected with the drive shaft of the car, which provides its power to the back wheels. Okay, that was a bit of a lie. It does depend if the car is front wheel driven or rear wheel driven. If it is rear wheel driven, it's gonna be at the back. The differential itself is, guess what, consisting of more gears. It has 4 main gears in total, with others being for additional support. The gear that is spinning with the drive shaft that's being spun by engine power, which is called a pinion gear. Why? I don't know. Then there's another gear, the ring gear, that's facing the drive shaft gear in a vertical position. And due to the push force exerted by the drive shaft gear, the second gear also spins. Outside it, there's a wheel connected to it and another gear, which is the side gear on the opposite side. Now, this is the gear that's going to make the most difference, pun intended, shut up. This gear, which is the spider gear, is going to connect the other side of the car too, making both rear wheels connected. Not only that, it's a special gear. A gear that can not only turn along with the big gear connecting 2 different wheel shafts, but also spin around its own axis. Bingo bango, how does it do that? When a car drives forward, the spider gear spins along with the gear ring, means that the spider gear remains static on its own axis. The side gears all spin at the same speeds. Now, let's just say we want to turn right, which means that the left side of the car is going to travel the longer distance. The spider gear is going to start turning to the right around its own axis, giving the left side of the car's wheels a higher distribution of torque. How does it understand to do that though? Well, since the car is turning, the rear wheels turn a very slight amount, but that very slight amount of turning actually makes sure that the side gear on the left side gets more velocity in a natural way, due to the fact that the inside wheel of the turn, which is in this instance the right side wheel, travels a shorter distance and the other side travels a longer one, which is what makes the spider gear spin around its own axis. You know what? I'm kind of getting bored, so I'm just gonna hop on like a Minecraft world to explain the last part. Hydraulic system! The system where fluid moves around and makes this goddamn cranky crawler work. But why is it needed and how does it do that? A hydraulic system uses fluid to put in under severe pressure to perform mechanical tasks such as controlling movements, transmitting power, and making sure that you can brake. In order to explain how the hydraulic system works, we have to understand what Pascal's law is. No! Pascal's law states that when a pressure is applied to a confined fluid, the pressure is transmitted equally in all directions. In other words, if you push enclosed fluid with a pump, you know, it will push the other pump outwards because the force will act upon it from the compressed fluid. The great thing with this law is that it can push a small area of fluid and have the compression move an even larger area of a pump. So in simpler words, you can push a smaller area to literally multiply force. The formula of this law is that pressure is equal to dividing force by an area, so it's a pretty simple formula. Let's just say you have a 50 centimeter radius sphere, applies 50 newtons of force on a piston, which will push a fluid to a bigger area of 5 square meters. Let's do this. Okay, firstly, I'll convert 50 centimeters to meters because centimeters are absolutely lame. It's like converting from playing Dota to like playing Counter-Strike next. Then we calculate the circle area by the formula PR squared because it's the area which applies the force. Then we divide the force with the area and we get the pressure answer. And now we know that this pressure is going to be the same at the other side and we know the area, so we can just calculate the new force, goddammit. You get that there. And boom! The force applied is now a whopping 318 times not times, 318.3 newtons. I think you get the point. The hydraulic system usually consists of several parts: fluid, which is mostly oil, obviously valves which control the direction of the fluid flow, pipes which transfer fluid between components, actuators, which are objects that just take any type of force or source of energy and turn it into motion, and finally a pump, which is responsible for creating pressure by, guess what, pressing the fluid. Oh my god. Okay, well, it does depend on the specific component if it's a pump or not, but the main point is it's something that compresses fluid. Okay, so how does the system work fully? Let's take braking, for example, because I clearly need some lessons on it. Firstly, don't you dare say anything bad about this 3D sketch. It's 2 AM and I want to go to goddamn sleep. It all starts with you obviously pressing the damn brake pedal, you know? Then that brake press pushes a piston inside the master cylinder, which you can think of as a pump, which presses a fluid, which is the braking fluid, and creates pressure. Afterwards, that pressure goes through these brake tubes, which you can consider to act as valves to the brake caliper. Once again, it's wrong. It's pipes, not valves, sorry. Which is the part which does the whole braking. By pushing 2 brake pads against the spinning brake disc to have it transfer all of the kinetic energy of the car to heat, which gets absorbed by the brake pads. And due to Pascal's law, the force of the piston pushed inside the master cylinder gets multiplied, which makes it actually possible to stop a 2-ton metal crate. I guess I could have just told you how bikes brake.